So this is just a quick video to explain how to identify the types of errors that you're coming across from the graph that you've plotted. Now, as you know, there are two types of errors. There are systematic and random. Now, just as a reminder, systematic errors affect every result by the same amount. For example, a calibration error that your multimeter or your ammeter is 0.01 amps out because it hasn't been calibrated properly. The best way to tell if you have a systematic error is to start off knowing what kind of relationship you have in the first place. Is it proportional or is it y equals mx plus c? A proportional relationship is simply y equals mx. I'll give you an example. Force equals mass times acceleration. That is a proportional relationship. A linear relationship is y equals mx plus c. So for example, s equals ut plus half at squared, right? So what you need to know first is what kind of relationship you are expecting. And if you're expecting a proportional relationship that goes through the origin here, yes, but your results are shifted. Your line is beautifully straight, but it's a little bit above on the y-axis, or it's shifted down, so you end up with an x-intercept. Okay, so if you've got this line here. If that is the case, then what you've got is a systematic error, because your errors are basically equal and are affecting all of your results by the same increment. Okay, so you can tell a constant systematic error on a graph if the line has shifted either up or down on the y-axis or on the x-axis for your particular predicted results. Random errors, however, do not repeat. They're all over the place. And so what you'll see if you have random errors is that you have a lot of disparity from your line of best fit. If your line of best fit is nice and straight, but your plotted points fall scattered all over the place, then you have got random errors. And of course, the more scatter there is, the more or the worse your random errors are. Okay, so your readings should lie within your error bars, right? If you've got random errors, you'll find that there's a lot of scatter. And in fact, these random errors might actually cause your error bars to be make it very, very difficult for your line to go through the error bars. If that happens, you have to do the experiment again. So you do have to be really careful with that.